What we're having a look at now is where we have an initial position on the chart, position A. We wish to reach position B. We have a set time to do this, and in this example it's 2 hours, and we are affected by current and leeway, so we need to calculate the course that we're going to steer to enable us to steam along this course line here on the chart and go from A to B. And we need to also calculate the speed that we need to go at to achieve this. So on the paper we've written here, calculate the course and speed to make good in order to go from position A to position B in 2 hours. The current is setting 350 at 2.4 knots, and the leeway is a southerly wind of 10 degrees. So how do we solve this problem? We're going from A to B. Had there been no wind, no leeway, we'd simply draw our course line as we've done here, and then we would measure the distance between A and B, divide that by 2, and that would be the speed. And we would go to the compass rose with this course, and of course that would be the course that the helmsman would steer. So what we need to do here is to counteract the current and the leeway in order that we make good this course on the chart to achieve our aim, which is to get to position B. Now with counteracting, if you remember, we always allow the current first and the leeway second. When it's an allowing problem, of course, it's leeway first, current second, but this is a counteracting, so we're going to allow the current first. The current is setting 350 at 2.4 knots. So we need to draw current, and we put the current at position A, of course. So that's where we are at position A, we set our current. Now the current is setting 2.4 knots. We need to put the current for 2 hours, because of course that's the time scale that we need to go from A to B. So whatever the time scale is, that's what you do for your current. So 2.4 twice is 4.8. So we set our current up to 4 and we'll call that C. So that position there, C, that represents the current setting 350 at 4.8 miles. And if you remember, current, it sets in the direction of the arrows, and it's 350. What we then do is join the vector triangle. So we join C, which is the end of the current, to B, and that will give us the course that we wish to make good in order to get to position B. So let's just measure that course on the compass rose, and that course is 132 degrees. We'll put one arrow on that, so in effect that is our water track. So if the helmsman steers 132, although the eraser's pointed towards 132, because of the current pushing us up this way, we will actually make good that course. So we write that on our answer script, that the water track is 132. Now we allow our leeway of 10 degrees. Now the leeway, it's a southerly wind, so it's blowing up from the south of 10 degrees. Now when you counteract, you have to steer into the wind. So in other words, our vessel that's going along here will have to steer into that wind to counteract the 10 degrees leeway. So in that regard, our ship's head will be 142 degrees. We've added 10 degrees because of the leeway. So the helmsman, to achieve this course from A to B of this course from A to B here, will have to steer a ship's head of 142 degrees. So the 142 degrees will enable us to go along this line here from A to B. Okay, so how long will it take us? Well, we've been told we've got 2 hours. What speed do we need to do to achieve reaching this position in 2 hours? Well, which distance do we measure off the chart? Had there been no current, we'd have of course just simply measured A to B. But because this current, as you can see, is setting us back, we have to measure the distance from C to B. So having allowed for the current, we measure from C to B. Had the current been setting over here somewhere, it would be evident that the distance would be less. But it's measured from C to B. So we'll just measure that distance. And that is 25.8 miles. So we have to steam a distance of 25.8 miles. We have to do that in 2 hours. Therefore, the speed that we'll have to make good is 12.9 knots. So if we do 12.9 knots and the helmsman steers 142, we will achieve going from A to B in the 2 hour time scale.